In this video, we're going to look at another measure of spread called the standard deviation. In short, it averages how far away every score is from the mean, from the average. Okay, we'll run this manually once, and then forevermore we'll use a calculator or a computer or whatever, but the main point in seeing the details of the calculation is so we understand what it does and how it responds to changes in the data, which we'll look at towards the end of this video. Okay, so this is the same data set we used for the mean, and back then we calculated that the average score here is 6. Now, it often won't actually be a number in the data set, but for us it just so happens to be. So that's 6 over there. And what we want to measure now is how far away everything is from 6. So let's start from the right side with 14. 14 minus 6 gives a distance of 8, so we'll store him there. Then we'll move to the score of 8. 8 minus 6 gives a distance of 2, so we'll put him there. 6 itself is of course exactly the mean, so it only makes sense to say the distance is 0, but we still have to include it. Okay, and now we're doing 5. To keep things consistent, we need to keep the calculation the same, which means we need to do 5 minus 6, just as we did 14 minus 6 and 8 minus 6. We got to go 5 minus 6. And so we're forced to put negative 1 there. Okay, that's the number we're going to have to store. Likewise for the 4. 4 minus 6 is negative 2, so we're going to take that one. Then there's another 4, meaning we need to take another copy of negative 2 over there. And finally, there's a 1, so 1 minus 6 is negative 5, and we take him. Now we aim to get the average distance from the mean, but in the process of averaging these numbers, we'd start by adding them. The problem here is that the negative numbers will be cancelling with the positives, which really ruins the whole point of everything we've just done, because we now detect no spread, okay? So now we could just force those numbers to be positive, and there is a version of this that just does that, just flips them all positive and then averages them, but more commonly we want to turn things positive in a numerically smooth way, and the best way to do that isn't to just abruptly rip off all the negative signs, but actually to square all the numbers, okay? Don't worry about why that makes it smooth, but it does. But anyway, now that they're positive, we can average them as normal by adding them up and then dividing by 7. But before we work out what that is, we need to recognize that all these numbers, these distances, have been squared. So to sort of rescale this back to normal, we wrap the whole thing in a huge square root. And that gives us a standard deviation of about 3.82, written with a symbol like that. It's a Greek letter S, or sigma. The good news is you're not likely to have to see that manual calculation ever again, and later on we'll show you how to do this on your calculator. So what was the point of doing all that? Well, the main thing you want to get from that is the standard deviation is a way of averaging these red distances from the mean, with a little detail of squaring and square rooting just to make it positive and all that, but we don't even have to worry about that, okay? It's sort of like just averaging those distances. So the first thing is that this is, so far, the only measure of spread that takes every single number into account. Okay, so far the measures of spread we've seen just don't do that. So the range only cares about the two end numbers and the difference between them. The interquartile range only cares about the quartiles and the difference between them. But the standard deviation is the only one so far we've seen that takes all the numbers into account, which has its advantages and disadvantages, much like the average, the mean. Okay, it's the one that would naturally carry the most information about every number in the data set, because it involves every number. But that in turn makes it heavily influenced by any outliers and stuff like that, so that's why we have a few different measures for both the center and spread, depending on what kind of data we're handling and what kind of information we want to get out of it. Okay, we'll discuss briefly also the way the standard deviation responds to changes in the data set. If every number is increased or decreased by the same amount, say we push them all up a bit, or maybe we decrease them all by a bit. Okay, these red distances, the length of those red gaps, they don't change, so our standard deviation stays the same. On the other hand, if we were to multiply or divide all the numbers by some amount, so say here we have halved everything, divided it all by 2, then the distances do get affected by that same scaling. Okay, so say if we halved all the numbers here, all the distances halve as well, so the standard deviation needs to be halved as well, and now it's gone down to 1.91. Okay, so as far as practical calculation goes, it is all on your calculator for now, so we'll show you that process maybe separately, but that's as much as you need to know for standard deviation. So thanks for watching, see you around.